Okay, it looks like I actually need to add myself. Looks like I actually need to add myself to the stream. It's been a rough morning, but I'm back. Back, we're here. We have sounds. Yes. Sorry about that. All right, cool. So this more, I'm gonna start over what I just said while nobody could hear me. Um, Implement secure cloud solutions. That's what we're going to do. AZ-204. This is the whole module, unlike everything else. Usually, I do one of those like modules, but this is like the whole path for secure cloud solutions because each module is like 21 minutes. So we're just gonna do that. Bang this out. Hopefully, it's not too crazy, but let's go. You can't read my mind yet. No. Well, gotta work on that. Okay. Not fair that people can't read my mind. All right. Azure Key Vault. Key Vault is a way to store secrets. So it's anything that, like they said, would tightly control access to things such as APIs, passwords, certificates, and keys. Um, so let's go. All right. So it supports two types of container vaults and the Azure Key Vault service supports two types of containers: vaults and manage our hardware security modules pools. Vault supporting storing software and HSM hardware security module, backed keys, secrets, and certificates. Manage HSM. I'm struggling today. I'm struggling hard. Managed HSM pools only support HSM backed keys. Azure Key Vault helps solve the following problem: secret management. Azure Key Vault can be used to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. Key management. Um, Key Vault makes it easy to create and control encryption keys to encrypt your data, and certificate management to control certificates. Well, you still can't hear anything, or you just we're good, right? In terms of sound. Oh, I know it's all good. I'm just reading and articulating while I read. I'm not the greatest at that. If I had to say things just from my mind, there would be no problem. But I don't want to make it boring and just reading the screen because you can read the screen on your own. So, okay. So as long as people can hear, good. Um, loud and loud. Great. Loud and clear. Okay. All right. Cool. Let's do that. So basically, Key Vault centralizes the secrets. So it's a great way when you develop an application. You say, I'm going to put all these secrets in one place. I'm going to give that application access to those secrets in that one place, as opposed to like, oh, I'm going to have some in memory. I'm going to have some in Key Vault, blah, blah, blah. And so it's much easier to store. It's basically like a password manager. Think about it this way, but not for um, applications. Password manager for applications. Security, store secrets and keys. Yes, everything is encrypted. I think you can't even decrypt it, right? Unless you have access. I think you can't even write to it, right? You can't overwrite programmatically. Um, Monitor access and use. Yeah, you can audit who's accessing what, and you can restrict access based on identity management, right? IAM. I don't know what it is. And simplify the administration of secrets, so you don't have to have in-house knowledge of hardware security modules. Scaling up on short notice to meet organization usage spike, replicating content of your key vault within the region, so you make sure that it's safe, and standard Azure administration options via Portal CLI and PowerShell, and automating certain tasks on certificate that you purchase from public certificate authorities, such as enrollment and renewal. I hate these abbreviation that are not explicitly said. All right. So you securely store and access secrets from there, tightly control access to. Are we just doing the same thing? Is it the same sentence? Yeah, it's basically the same sentence. Come on, go back. Go forward. There you go. All right. So you can use managed identities. There's 3 ways to authenticate to Key Vault. Managed identities, so service principal names for Azure Resources. So the cool thing you have in Azure is that you can assign identities to certain services and certain resources through service principal names and managed identities and what have you. So you can control access through these managed identities. You're basically turning an application into a person. And so if an application needs access to a secret or another storage account or what have you in Azure, you have an assigned identity. I don't know that all resources are able to have an assigned identity. Compute, a lot of compute resources tend to have that. But what this means basically when you have a managed identity, service principal, is that you can then control access at the resource level as opposed to storing a key in your application type of thing, right? It has access because it is this application rather than because it has the key. I hope this distinction makes sense. Service principal and certificate, so you can authenticate through that. So if you have a certificate, you can just be like, hey, here's my certificate. And then you can authenticate and get access to the secrets you need. And you can also use it with a secret to authenticate to Key Vault. Encryption of data in transit. Everything is encrypted to make sure that the application, only who needs access to the secret gets access to the secret. Sorry, 1 second. I gotta. Sorry about that. All right. Best practices: you separate key vaults per application, per environment. All right. So you can have. The good thing if you do this is you can basically have the same secret name, right, in different key vaults for different stages of the same application, and you can move your application through the stages without really saying this is the production secret and this is the test secret and this is the development secret. And you can also make sure that less breaches. Control access to your vault, so you can only authorize application and users. Backup, you need to back up, obviously. Log who's accessing your vault, and turn on self-delete. Self-delete, same thing as blobs, where you can just say, hey, if you delete the secret, it's going to be available for X amount of time before it gets permanently deleted. All right, so you can enable authentication with Key Vault. Works in conjunction with Active Directory, which is responsible for authenticating identity of any given security principal. Enable system assigned managed identity for the application. If you cannot use managed identity, instead register the application with your Azure AD tenant. Registration also creates a second application object that identifies the apps across all tenants. They recommend system assigned identity. Um, Authentication to key vault in application code. Any preference? I think when I asked for language, people were like, "Hey, I want Python." So we're gonna look at the Python SDK. Azure Identity Client Library for Python. Pip install Azure Identity. Um, okay, default Azure credentials details. Hmm. Hmm. Okay. Um, I don't see anything that I can really talk about. What is default credentials? Um, Default credential capable of handling most Azure SDK authentication scenarios. The identity it uses depends on the environment. When an access token is needed, it requests one using these identities in turn, stopping when one provides a token. A service principal configured by environment variable. There's your managed identity. Windows only, a user sign into Microsoft application. Visual Studio Code, Azure CLI, and PowerShell. Wow, I feel the hate right there. Microsoft. PowerShell last? Rude. I don't care. It's the same thing. Okay, so basically you configure an identity in your environment. Probably you would do a service principal or a managed identity. Okay. You would just use a managed identity, and then once you use everything else in the SDK, once you've authenticated, you would just use that. Okay. Okay. Authentication to key vault with REST must be sent to the service. You need to have a bearer token, so you need to authenticate first. So here, that's what they're saying. That's you do the. No, that's not what they're saying. Yeah, you have to authenticate basically. When an access token is not supplied or when a token is not accepted by service, will be returned. Right, so you basically have to authenticate. So you need authorization, the auth to service to obtain the token for the request and request resource. Yep. Okay. Set a retrieve from Azure Key Vault by using Azure CLI. Cloud Shell, Bash, create a key vault. Come on. All right. Can you go right here? Okay. We're struggling today. We're struggling. I have no idea why we're struggling this much this morning. Okay. I'm just trying to make it so that I can have. There we go. All right. So we go to CLI. Right here. Can I? I don't want to zoom in. I want to make it bigger. Okay. All right. Oh, I'm in PowerShell. Never mind. Let's go to Bash, confirm. It's a little annoying. 1 second. Better. Okay. Just 1 second. Let me make sure I'm in the right subscription. Just don't really want to show. All that information. Okay. All right. I'm back. Sorry. All right, cool. So let's get this. Paste. Allocation. I'm going to create a resource group. Allocation. We created a resource group. Now we're going to create a key vault. Come on. How's everybody's weekend doing? I'm just waiting for this to be done. In between streams, I've been trying to fix a vacuum. It's a lot harder than it looks. So much work. It just never ends. It just never ends. This is actually taking a lot longer than I thought it would for a key vault. Oh, it was just registering the service. So if you've played with Azure before, not all services are enabled by default. You're not allowed. It's not that you're not allowed. It's just not accessible by default, right? So that's what it's doing. It's saying, hey, this API is now available to this subscription. Let me just make it available. That's what it did. That's why it took a little bit longer. And now the key vault is there. Okay. Let's create a secret. Come on. All right, secret was created. And let's show the secret. All right, and now we get the same value. So AZ key vault secret show name, you have to say the name, vault name, the name of the vault, and then it gives it to you. Cool. And yeah, we get this value, blah, blah, blah. Clean up the resources. Let's do this. Sure. All right. Knowledge check. Which of the below methods of authenticating to Azure Key Vault is recommended in most scenario? It really likes managed identities the most. Key Vault products data when it is traveling between Azure Key Vault and clients. What protocol does it use for encryption? Transport layer security. That's what I remember it said. Um, yeah. Yes. No, wait. I want to see the answers. What happens if I do this? Oh, hey, cool. Can I do another one? All right, service principal and secret. This method is not recommended because the application owner must develop or rotate the certificate. Yes. Wait, what? I think that's the wrong answer. But yeah, so basically, they don't like when you use a secret or a certificate because then you are responsible for basically handling the key. And since people are idiots, everyone, including me, um, managing keys is not the easiest thing. And so if you use a managed identity, then by virtue of existing, the application will have access. At TLS, okay, let me try to get okay, so SSL has been replaced with TLS. I'm just trying to see what the reasoning for all the answers is. Personalization layer is part of open system interaction model and is not a security protocol. Okay. Yes. All right, cool. So we've done the key vault. And now we're at managed identities. So that's what we were talking about. Explain the difference between two types of managed identities. I'm assuming user and system assigned managed identities. Yes. Configure managed identities and require access token by using REST and code. Yes, because it's a developer one. Okay. So system assigned managed identity is enabled directly on an Azure service instance. When the identity is enabled, Azure creates an identity for the instance in the Azure Active Directory tenant that's trusted by the subscription of the instance. After the identity is created, the credentials are provisioned onto the instance. The lifecycle of a system assigned identity is directly tied to the Azure service instance that's enabled on it. If the instance is deleted, Azure automatically cleans up the credentials and the identity in Azure AD. And one thing that is good for system managed identities, assigned managed identities, is that you don't actually need permissions. In my experience, you don't actually need permissions to Azure AD in order to create the managed identity. At work, for example, I do not have access to Azure AD. I can read, but I can't write Azure AD. It's a whole topic. But I am able to create system assigned managed identity because this is done by Azure and not the user. So that's one advantage of it. Is a developer could create an application with a managed identity, a system assigned managed identity, and not need access to Azure Active Directory to create that identity or need somebody else to create that identity for them. Yeah. A user-assigned managed identity is created as a standalone Azure resource through a create process. Azure creates an identity in the Azure AD tenant that's trusted by the subscription in use. After the identity is created, the identity can be assigned to one or more Azure service instances. The lifecycle of user assigned identity is managed separately from the lifecycle of the Azure service instances to which it is assigned. So, what I understand, are we going to go through more? What I understand here is basically if you have a user assigned identity, the advantage is you can assign it to more than one resource, unlike the system assigned identity. The downside of the user assigned managed identity is that you, as the owner, are in charge of that identity. So you can't just say, hey, delete those resources and the identity goes away. No. In this case, you are responsible for the life cycle. So if this identity is not assigned to anything and just there and chilling, then it's your mess to clean up. Whereas a system assigned identity will be cleaned up. The lifecycle of the identity is tied to the lifecycle of the application. Yeah. All right. Characteristic of managed identities. The system assigned criterion created as part of Azure Resource, for example, an Azure Virtual Machine, blah, 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 and it's standalone. So, okay, so system assigned, linked to a resource, user assigned, standalone. Lifecycle, that's what I was saying. Lifecycle is tied to the resource that it's created with. When the parent resource is deleted, the managed identity is deleted as well. The lifecycle of a user managed identity is owner dependent. One other thing that I was just thinking about of a user managed identity, one advantage of having a user managed identity is that if you do deployments for an application and things like that, and you use a user managed identity, that means that you are able to say delete a resource and grant the same access through the managed identity to a new resource. So an example of that would be, let's say you create an Azure function and you then have a managed identity assigned to that Azure function to have access to a key vault. But you messed up, right? You created the wrong function type, right? You do an app service plan so you can have private network. You created just the consumption Azure function, so it's all public and you can't have access to a private network. In that case, if you used a system assigned identity, when you recreate that function, when you delete that function and you recreate it properly with the app service plan, and you use a system assigned identity, you will have to re-give permission to that new identity to everything you gave permission to previously, right, to the other application. So that makes migration a lot harder. But if you use a user-assigned managed identity, you can just take that identity from your original Azure function, assign it to the new Azure function without having to do more than that to grant access. So that's an advantage. But the downside is you are responsible for that identity. So there's pros and cons. All right, sharing across Azure resources cannot be shared, can only be associated with a single Azure resource for a system and managed one, system assigned one. And this one can be shared. You can use the same managed identity with more than one Azure resource. Why would you want to do that? Well, one advantage of this is that you can, for example, deploy Let's say you have an Azure function. We'll go back to Azure function. Let's just do web app, right? Let's do web app. You have a web app that has access to resources, but you want to scale that globally. And so because a web app doesn't scale globally, you will have to have multiple web apps in different locations, and you will have to maybe load balance the web app, whatever. But you want all the new web apps that you deploy every time to have the same access to the same resources. So if you use one shared, one managed identity, you can share that identity and that access across all your web apps, across all your regions, and not have to recreate all the permissions every time you deploy to a new region. So, yeah. Oh, hey, cool. They tell you. Okay, when to use managed identities. The image below gives you an overview of the scenario that support using managed identities. For example, you can use managed identities if you want to build an app using Azure App Services that accesses Azure storage without having to manage credentials. Okay, so I want to build an app using virtual machines or app services or functions or container instances or storage or Kubernetes, etc. As you can see, the managed identity is for compute, right? If you think about it, it makes sense that the managed identity would be in compute because, well, that's the thing that actually does any actions. So those are the services that will have managed identities. If I'm correct in what I just said, we should not be able to assign a managed identity to a storage account because a storage account doesn't actually read anything. So let's go to Azure. Can I quit this? Let's quit this. Sure. Let's get this storage account. We have access keys. Can we? Oh, command slash. If we can find anything about identity. See, there's no identity here. So, ta-da. So, yeah. Let's do functions. I just want to show you function app. Have a few on here. Is this here? Well, you know what? We can create one if we want. Here you have identity on your function. And okay, so here there's no identity assigned. And you can have a user assign one and you can just add. Oh, can you add more than one identity? One second. Okay, we'll go back to that. Maybe they'll show you how to create. Oh, hey, what services support managed identities? Managed identities for resources can be used, for Azure Resources can be used to authenticate to services that support Active Directory authentication. For a list of Azure services that support managed identities for Azure Resources features, visit services that support managed identity for Azure Resources. The rest of this module will use Azure Virtual Machines in its examples. Okay. Where are we looking? Did I? Oh, here. So API management, gateway, automation, batch blueprints, cognitive services, data box, data explorer, data factory, data lake. data share, digital twins, even grid image builder, import export, Kubernetes, logic apps, log analytics, machine learning, manage disks, monitor policy purview, resource mover, site recovery, search fabric, SQL stack, Synapse. Yeah. So all of them has some compute component to them. Um, okay. So what I see here is, sorry, I really have to sneeze. I guess I didn't have to sneeze. Okay, cool. No, wrong one. Right. Discover managed identity authentication workflow. How a system and assign managed identity works with Azure Virtual Machine. The resource manager receives a request to enable the system assigned managed identity on the virtual machine. The Azure Resource Manager creates a service principal in Azure Active Directory for the identity of the virtual machine. The service principal is created in the Azure Active Directory tenant that's trusted by the subscription. See here, you do not Azure, so it's independent of your permission. You may have to have owner permission, but it's independent of your permissions in Active Directory. Um, okay, Azure Resource Manager configures the identity on the virtual machine by updating the Azure Instance Metadata Service Identity Endpoint. That's a mouthful. With the Service Principal Client ID and Certificate. After the virtual machine has an identity, use the service principal information to grant the virtual machine access to Azure resources. To call Azure Resource Manager, use role-based access control in Azure Active Directory to assign the appropriate role to the virtual machine service principal. To call Key Vault, grant your code access to the specific secret in Key Vault. Okay. Your code that's running on the virtual machine can request a token from the Azure Instance Metadata Service endpoint, accessible only from within the virtual machine. 169. Um, is this like always the same address? That's a question I have. Do you want to Google this? I want to Google it. Is this the IP address of the machine, or is it always the same IP address? Okay. So this is okay. I know we're looking at AWS, but apparently they all use the same IP address to say, hey, we're going to distribute metadata service. Okay. All right, cool. Good to know. So I don't think you're going to need to know the IP address. Oh, actually, that's not hard. It's 169.254.169.254. Okay. But, I mean, so yeah, so everybody uses the same thing, and it's going to retrieve a token for the machine you're on. Okay, a call is made to Azure Active Directory to request an access token specified in step 5 by using the client ID and certificate configured in step 3. Azure Active Directory returns a JSON Web Token (JWT). Your code sends the access token on a call to a service that supports Active Directory. Okay. All right. I hope this makes sense. Basically, you create your resource. You say, I want to enable a System assign managed identity. Azure Resource Manager is like, hey, let me create the identity on Azure Active Directory. Then it goes back to the virtual machine and says, hey, here's the metadata for the identity you have assigned to you. When you have to have a token based on like the virtual machine having access, you just say, you just go here, you get your token because your virtual machine has all the metadata in it for the identity. You don't even need to worry about the identity, right? It's using the metadata service endpoint. You go here. This calls Active Directory, which then gives you a token, and then you can send the token to other services that use Active Directory authentication, right? So that's very practical because then you don't really have to worry about authentication, right? You just go here, retrieve your token, and then use it. Nothing else matters. All right, how user managed identity works with an Azure virtual machine. Okay, so the user creates a user assigned managed identity, right, in the resource manager. Azure Resource Manager does everything in Azure, right? But that's what happens. Creates a service principal in Azure Active Directory for the user assigned managed identity. And then I'm assuming everything else is the same, right? It's created. Okay. The received a request to configure the user managed identity on the virtual machine. So when you tell it to do that, it's gonna use the update the metadata. After the user managed identity is created, use the service principal information to grant the identity access to Azure Resources. Okay. To call Azure Resource Manager, use role-based access control. Oh, my mouth. Role-based access control in Azure Active Directory to assign the appropriate role to the service principal of the user assigned identity. To call Key Vault, grant your code access to the specific secret in Key Vault. Your code, and then everything is the same, right? Go to the metadata to get the token. It has Active Directory, which then gives you an access token, and then you use access token to reuse. That's really, the only difference is this is the manual process to do that. Okay. All right, let's go back to Azure. All right, let's go back to Azure. Actually, let me go back to the proper description. Yeah. Cool. Okay. Let's go here. Let's move this a little bit to the side. All right, we're just going to copy this. I'll be surprised if this actually works. Why doesn't this work? Okay, this is frustrating, but okay, we'll do this. Can I not do this? Yeah. And can I do this? Why are you thinking that? Oh, all right. Then we gonna have to do this. There's new character at the end of the line. New line character. All right, so this is pretty straightforward. Basically, create a Azure virtual machine provider. Create a virtual machine in the resource group, my resource group, which does not exist. So I'm assuming this is going to fail. The virtual machine name will be my VM. The image Windows 2016 data center. You generate an SSH key. You assign an identity. That's the system assigned identity. The admin user admin password. That's what I thought. Okay, so AZ group create. Is it my resource group? Never mind. Wait, what? What did I do? Oh, what am I? I just don't know what is happening. You hope I'm not feeling tired. I'm glad I don't look tired to you, but I am very tired. But yeah, I try to do that every weekend. 3 live streams just to to force me to do the studying and to allow you to force yourselves to do studying while I do the live stream. So feel free to put the live stream on, have me as a background sound, or turn off the sound and just do the studying while I do the studying. But feel free to ask questions too. Um, what did I do? Easy group create. Okay, so you want resource group. I honestly do not use the Azure CLI. That is not something I do on a regular basis. If I do anything, I use PowerShell. Much easier. But yeah. Do I have a free account? No, I pay for all my Azure bill. I used to have a free account. I think it lasts like a month where you get $200 worth of credit, and then you have services free for 1 year. I've been doing this for a little bit, let's say, and so my free account expired, but it's fine. I have an Azure bill of about $10 per month, which is something I can manage. I have budget alerts to make sure that I know that I don't go over budget, to make sure that I watch what I do in Azure. So yeah. But the good thing about doing this and paying for yourself is that it forces you to learn some best practices in Azure and to learn how to manage your resources properly and manage your subscription properly. And it forces you to be creative on how you use your resources so that you don't pay too much money. I hope this answered your question. But yeah, so that's how I do things. Oof, it's exhausting. You get $100. You get $150 for free every month on your Azure account. Can I suggest how to use them? I mean, if you get them for free, I mean, it really depends on what you do. I would say still delete your resources, but I mean, $100 is one virtual machine. $150 is one virtual machine. So it goes fast very. If it goes away very fast. Um, what I would recommend is if you want to do applications or Kubernetes or things like this, host your own website, put more stuff in the backend, use an app service plan, run containers, things like that. I think if you have money to use a lot of resources in Azure, especially pricier non-consumption ones, that's what I would call them, non-serverless. Sorry. Um, yeah, I would say use that. I hope this made sense. But yeah, use that. Make a good cloud portfolio. Try to use as many services. So especially in this one, it talks to you. The AZ-200 talks to you 204. 204 teaches you about message passing between, you know, queues and event hubs and event grid, not even hub, event grid, um, message bus, message services bus, or whatever. Um, yeah, build something nice with that, um, and use that. I wouldn't force yourself to use $150 on your account, honestly. Um, but yeah. All right, so let's assign an identity. Do, do, do. You're welcome. All right, so it didn't have an identity. Oh, it did have an identity. Okay. So here, what you see is it was like, oh, I don't know why they did that, but it already had an identity assigned. Then it assigned a new one. Let's um, okay, identity here. There you go. So I think it reassigned an identity here. It probably already had one because of the switch we used. Um, yeah, so we have those things. And then you can do role assignments here. Um, I don't know why it's been so. This is frustrating. Okay. To assign a user assigned identity to a virtual machine during integration, your account needs virtual machine contributor and managed identity operator role assignments. No additional Azure AD directory roles are required. Okay. Enabling user assigned identity as a steps. Create the assigned identity and assign it. All right. So create an identity. Come on. Okay. That's a lot. Um, wow. Now I have to write Now I have to write things. That's very annoying. All right. AZ-VM create resource. Group. No. Name as VM02. Image Ubuntu long-term service, and then here's your name, and then password, and then 123, mark, assign entity, and user send identity name. All right. And let's create that. Okay. You want to fight? Wow. That's why I like PowerShell because it has a complete. What is wrong with you? Oh, because it's Ubuntu. It's Ubuntu. All right. Okay. So while this is going, any questions? I think I'm just gonna. Has a public IP address. We'll stop this. Okay. I don't need it. Do we need it? No, we're gonna use it later. Right, the VM is created. I don't like that they have public IP addresses. Let's see. AZ VM identity assign E for resource group. My resource group. And VM empty space. And do we want to do this? Yeah. While this is doing its thing, let's go back here. Let's look at this one. And in theory, we should be able to go user assigned. And there you go. It's here. Look at the VMs. Refresh. There's VM02. Stop. And like these. Then we have identity. You can see there's no system assigned and there's a user assigned. one, and it's the same as the other one, which is amazing. Um, all right, come on, there we go. Did you just do this? This is unacceptable. Okay, all right. You can look at the SDKs on your own. Let's go to next. Query Nexus token. Okay, so you basically do basic get. Oh, okay. So you use API version, you say the resource you want a token for, and then to get the IP address that we saw, 169.204, blah, 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 resource, metadata, true. And it's HTTP request header field required by managed identities for, okay. So this is how you do it in, what is it called? What is it called? Whatever. HTTP, whatever. C#, create a web request like this. You have the header, you call it blah, blah, blah. Then you cache it, whatever. Okay, so you should cache it, and you should also, so you cache it so you don't have to request it every time, and you also should prepare for scenarios where that indicates where the token expired, so refresh the token call. Now let's check. Which of the following characteristic is indicative of user assigned identity? Shared lifecycle with an Azure resource? No, because that's a managed identity. It shares the same lifecycle as the resource. Independent lifecycle? Yes. Can only be associated with a single Azure resource? No, that's still a system managed. System assigned managed identity. Okay. Client app requests managed. A client app requests manage identities for an access token for a given resource. Okay. Which of the below is the basis for the token? OAuth 2.0. Yes, that's the authorization. Service principal. No, it's not using a service principal to get the token. And it's not a virtual machine. Okay, wow. Rude. Oh. Oh, okay. I understand the question. Like the it's see that's tricky because see it's using OAuth 2, right? It's there, but I'm gonna put this back. So it is the protocol used to get it, but basically what this means is what is the identity used, right? It's in my opinion the phrasing is a little bit tricky. Yes, it's a OAuth 2 protocol using a service principal as as the identity used for this. Managed identity is service principal. All right, cool. All right. I'm actually tired for this one, so instead of finishing it, I'm just gonna go rest my brain cells to the next one, which is in 40 minutes. So, all right. Hope this was helpful, and I'll see you in the next one. If my brain doesn't decide to cancel it because it's fried, but yeah. All right. See you soon. Bye.